Hello, my name is Andrei Smirnov, and today I'm going to talk about one of the new features of Talos 1.5, which we called KubePrism. Uh, KubePrism is in cluster, so it runs inside the cluster Kubernetes API load balancer, which solves the problem of running the cluster smoothly even in case when the external Kubernetes API load balancer fails. But let's first talk a bit about the problem that KubePrism tries to solve. Usually, if we want to run highly available Kubernetes cluster, we need to make sure that we run several control plane nodes, and because of the etcd quorum requirements, we usually run 3 of them. Each control plane node runs an instance of the Kube API server, which actually provides the Kubernetes API. And in front of all control plane machines, we run a load balancer, which first of all load balances traffic across all control plane nodes. And also in case if one control plane node fails, it redirects the traffic to avoid hitting a failed node. And usually when we access the cluster ourselves externally or using some automated tools, we go through the load balancer, which actually proxies the traffic to an actual control plane node, which runs our request, returns the response back through the load balancer. This all works great, and the load balancer could be a TCP load balancer, a real one. It could be a DNS name, which points to several IP addresses. It could be a virtual IP. It doesn't actually matter how it is implemented. And like we discussed in the case of a failure of a node, or if the Kube API server fails, for example, when we are upgrading it and it went down and it's going to be up with the new version, or we're just trying new configuration on a single node and we misconfigured it, the load balancer will take care that the requests are still flowing normally to the healthy control plane nodes. But what happens if the load balancer itself fails? Once again, for whatever reason, it could be misconfigured or it failed or anything like that. It might seem that in this case, what we're going to lose is just the external access to the cluster. So we can't use kubectl anymore to access the cluster, but the cluster itself should be healthy. Turns out it's not so easy, and we need to dig a bit deeper to understand why. Let's imagine that we're running inside the cluster in a pod with the CNI networking, and inside that pod we're trying to access some Kubernetes service. For example, Kubernetes provides a service which allows to access Kubernetes API itself. This service is only valid or available inside the cluster, and more specifically inside the pods which run with the pod networking. They're not available in the pods which run with host networking. So what happens when we try to curl this kubernetes.default.service? First of all, there will be a DNS resolution which will go to the core DNS pod, which will resolve that name into the what is called a service IP. Then the traffic will go out to that service IP, and kubeproxy, or in case if you're running CNI, which replaces kubeproxy, some equivalent of that, will figure out how to map that service IP to the actual pod IPs. In case of Kubernetes API, the pod IPs of the Kube API server pods, which will be just simply node IPs of the control plane. And finally, either using IP tables or eBPF or any other solution, the traffic will be redirected to these pod IPs. That all seems to be fine, but how does core DNS, and how does kubeproxy know how to access, how to map the, for example, the DNS name to a service IP, or how to map a service IP to the node IPs? And the answer is actually easy. They need to talk to the Kubernetes API server. So basically, what is happening if we expand our diagram a bit and we add not only control plane nodes, which are in light yellow, like 3 on top. These run Kube API server, the control plane nodes, and also we have some worker nodes. And these nodes run our workloads. And actually, on every node in the default installation of Kubernetes, we have a kubeproxy pod, which runs as a Kubernetes daemon set. And this kubeproxy pod handles the resolution of the service IP to pod IPs and actually handling this traffic. And kubeproxy needs to reach out to the Kubernetes API server. But how can it do it? How can it do that? Because kubeproxy itself runs with the host networking mode, because it can't run in the pod networking mode because it provides services for actually pods running in the pod networking mode. So it will use by default the endpoint of your Kubernetes API cluster, and that endpoint is, of course, your load balancer. So getting back, what if the load balancer fails? In that case, kubeproxy will be cut from the Kubernetes API, and it enters what they call kind of a failure mode. In this mode, kubeproxy will keep doing whatever it was doing before, so basically proxying the connections that it knows about already, but it won't be able to access any information from the API server, any changes whatsoever. And also, what actually happens when the Kubernetes API load balancer goes down, or in other words, what happens when your cluster endpoint goes down? The most visible, and I think the problem that most people have already seen, is that all kinds of ingresses go down almost immediately. The second thing is that the kubelet running on the node, and it also runs in the host networking, is using the Kubernetes API endpoint to reach out to the API server to figure out what pods should be running on this node, and also to report its status, so that communication gets disrupted. So no new pods can run, and even if some pods fail, kubelet can't report that back to the API server, so there won't be any action to reschedule them. So basically, cluster things that were running will probably keep running. Some things are more sensitive, like ingress controllers. Some things might happen in a bad way, because we know, right, if some pod fails, API server doesn't know about that, kube scheduler doesn't know about that, and so on. But the ingress going down is a big problem, because it's quite often that what we run in the cluster is some kind of a web API, web backend, frontend that needs to be exposed to the world. And if the ingress is down, nothing else matters. Our whole system is down. How KubePrism tries to solve that? KubePrism schedules a load balancer, a tiny load balancer, on every machine in the cluster. That load balancer is bound to the local host, so it's only available to that specific node. And this load balancer takes care of proxying traffic to the Kubernetes API server running on control plane nodes in a safe way, so that it will always try to reach out to the API server, even if the load balancer is down. It will basically work around the load balancer and reach out to the nodes directly. When KubePrism is enabled, every component which was using the default Kubernetes API endpoint is reconfigured to use the KubePrism load balancer endpoint instead. And this way, even if the load balancer goes down, the traffic to the Kubernetes API server is not affected. Yes, in this case, we'll still lose external access to the cluster, but at least the cluster itself will keep working correctly. So a few words, a few details about the KubePrism. It runs a load balancer. Like I said, it runs it on the local host. The idea is that this load balancer doesn't expose the Kubernetes API externally in any way. So that's not a security issue. The load balancer runs on the same endpoint on every node so that we can use its endpoint in daemon sets, because for a daemon set, we can't configure anything specific for each machine, or it's hard to do that. We can use the same endpoint for all pods of the daemon set because the KubePrism load balancer endpoint is same for all nodes. And we can use it for all pods or services running in the cluster which run with the host networking mode, because if pod runs with pod networking, the local host will be the local host of the pod itself, not the host or machine's local host. We can use it for any pods which run with host networking and need to reach out to the Kubernetes API. Some CNIs like Calico, they depend on Kubernetes API, so they're very sensitive to issues with the Kubernetes API. kubeproxy, like we discussed, kubelet, and so on. What are the upstreams? So where does the KubePrism load balancer try to send the traffic to? First of all, it will try to use the existing external load balancer, basically the Kubernetes API endpoint. So in any case, it's no worse than just using the Kubernetes API endpoint because it's one of the upstreams. Also, KubePrism will learn the direct node IPs of the control plane nodes and will use them directly to talk to the control planes. And it will automatically handle cases when new control plane nodes are added or removed. And also on control plane nodes, when we run on control plane node itself, we have a Kube API server on the same node, which we can use. So control plane nodes can use localhost as an additional endpoint. What KubePrism load balancer does next, it runs the health checks on all the upstreams and figures out which ones are healthy or unhealthy. It could be that the control plane node is down, or just simply this worker node can't reach out to this control plane node because of some network restrictions, then it will be excluded from the list. It also measures latency by several tiers so that it knows which of the endpoints are closer. For example, the load balancer might be farther away from the cluster while all the nodes run in the same local area network, so they can actually reaching out to the control plane directly has lower latency than going through the load balancer. In that case, KubePrism will prefer that. And also, as you might imagine, if the localhost endpoint is available, like control plane node, like some workload on the control plane node itself tries to talk to the API server, they could use the localhost. So the traffic actually never leaves the node. And in that case, the latency is minimal. But enough talking, and I'm going to demo KubePrism for you. So you can actually see how it works. So for the demo, I have a Talos Linux cluster running in QEMU on my machine. As you can see, I have 5 nodes, 3 control plane nodes and 2 workers. It's running latest Kubernetes 128.2 at the moment of recording this video. And what I'm going to do, like, this cluster is pretty much empty. It runs nothing, just the control plane, pods, core DNS, CNI, which is Flannel, and kubeproxy as a daemon set. I'm going to deploy there Nginx ingress controller and deploy some test workload and expose that using the ingress controller. At the moment, KubePrism is not enabled, right? So I have a load balancer for this cluster, which is a simple TCP load balancer, which runs as a process on my machine, so I can easily control that. I can stop that process, which will basically simulate failure of the load balancer. So I have ingress Nginx deployed. Now it should be coming up. It's running. So I can create a demo deployment, which runs basically HTTP server that I'm going to expose, and I'm going to create a service for this deployment. And then I can create an ingress for my demo service with the host demo.localdev.me. And once I have that created, I should have the ingress itself is exposed as a load balancer, but I don't have like not a cloud environment. I don't have an actual load balancer, so I'm going to use the node port address here to access the ingress, and ingress should proxy traffic to my test deployment. So let's see if it works. So I have a curl command here, which I will run with the watch, so we can see whether our deployment works or not. So here it goes. This HTML response is coming through the ingress, which proxies traffic to this demo deployment and back to me. So the ingress is working at the moment. As I have watch running, it will update itself if something goes wrong. So once again, KubePrism is not enabled, so cluster is using the external cluster endpoint, which is presented with the simple TCP load balancer running on my machine. So what I'm going to do is I'm going to stop that process, and that will basically kill the external load balancer. And let's see what is going to happen. So I'm stopping the load balancer right now. So, well, almost now actually stopped it. Let's see, the ingress still works so far. And it will take several seconds for things to change, but we should see that. So we can do kubectl get nodes, for example, and that doesn't work because kubectl is using external load balancers, so it doesn't work anymore. But what I can do to restore my access to the node is to override the endpoint here with the direct IP address of one of the control plane nodes. Okay, and while I was doing that, you can see in the bottom of the screen that ingress stopped working, and probably many of you saw that happening to their clusters. So even though my cluster is still running and pods are still running, nothing bad actually happened. The ingress is down, and if that was my production cluster, like all external access to my web API or a website or whatever else I was running is now down. So I'm going to restore my kubectl access, so I can now do get nodes. And what you can immediately see that workers transitioned into the not ready state, which means that the kubelet can't reach out to the control plane nodes. The control plane nodes themselves are still ready because the kubelet there is configured by Talos Linux to use the localhost endpoint. So basically they are self-sufficient. The kubelet talks to itself. We can verify that the pods are still running. Well, that was the latest state, which was reported. Like we can see these demo pod, the Ingress Nginx is running. Everything is more or less fine with this cluster, but the ingress is broken. So what I can do, I can try to enable KubePrism, and I can even enable that on the fly. So the KubePrism is enabled with a simple flip of a flag in the Talos machine configuration, which I have here as a config patch. And I can now apply this config patch to all my nodes. I have 5 nodes, and I'm running a command patch machine configuration, and I'm passing the name of the file which contains the patch and also specifying all my nodes. This configuration is applied in real time, and what is happening, Talos launched the KubePrism load balancer, and by the way, you can see my ingress is back now. And the only reason it's back because KubePrism load balancer took over the work that was done by the load balancer, like external one, which I have like in this failed state. Once again, KubePrism doesn't help me to restore my external access to the cluster. It only helps to ensure internal connectivity between the nodes. So then internally, the Kubernetes API server is always available. Once I have KubePrism enabled, one thing I might want to do is to make sure that all Kubernetes manifests are updated to use the KubePrism. If you installed CNI yourself, you will have to configure that in the CNI deployment. But in my case, I'm running kubeproxy. kubeproxy is managed by Talos, so I can actually ask Talos to reconfigure Kubernetes manifests. So I can use the upgrade Kates command. In a kind of a dry run mode, I will tell it to upgrade to the same version of Kubernetes that I'm running right now. And I also pass it a custom Kubernetes API endpoint, because by default, it will try to use the configured endpoint, which is a load balancer, and that load balancer is down. So I need to work around that case. It will quickly goes through items because there is nothing to be applied. But in one of the manifests, as you can see, it reconfigures the, that's a config map, which is used by kubeproxy to access the Kubernetes API. And it reconfigures it. Instead of using the load balancer endpoint, it's now using the KubePrism load balancer endpoint. So, and like I said, as this endpoint is same on all machines, and despite this being a daemon set, it should work. And I can check whether my kubeproxy pods picked up the change. So what I can do, I can ask for the logs. And you can see it's basically still failing. And what I can do, I can ask the Kubernetes to roll out the kubeproxy pods to pick up the changes. And and by the way, the rollout works. And the reason that it works, because my cluster, which I think I forgot to show, is now all my kubelets and my nodes are back to ready state because KubePrism established that connectivity. So what I should see that kubeproxy pods got restarted. And if I once again look into the logs, it shouldn't report any failures anymore because it can talk. But my Kubernetes API external load balancer, the one which the cluster was created with, is still down. And despite that, my cluster is healthy, the ingress is working, and all the uh, traffic in my cluster is unaffected. Um, that's all for this demo. And as a closing note, what I can say that in this demo, I took a cluster which didn't have KubePrism enabled and enabled that on the fly. And that was just to show the failure scenario and how to get out of that. But if you are creating your cluster for the first time, of course, you can create it with the KubePrism enabled initially. That would avoid these problems in the first place. And one more note, if you're deploying CNIs like Cilium, Calico, make sure that they use this KubePrism endpoint instead of the default Kubernetes API endpoint. And KubePrism endpoint is very simple. It's always HTTPS, localhost, and the port is the one you pick up in the machine config. The only requirement for this port to be available on every machine and to be the same. And with that, you get much better availability of your Kubernetes API clusters. So thanks for watching. And if you have any questions, please reach out to us in GitHub issues or discussions. Thank you. Have a great day.